So when you're dealing with a geometric sum, in other words, a set of numbers that keeps getting bigger or smaller depending on a certain ratio, that can go one of two ways, especially in the case of this being infinite, right? When you see that infinity symbol right there, you have two choices. Is it converging or is it diverging? Well, converging has a special meaning. That means those numbers, even though there's an infinite number of them, those numbers are getting smaller, like 8, 4, 2, 1, 1/2, and so on. And in that case, you actually can add them all up and you get a result that's not D&E. But if the numbers are diverging, if they're getting bigger, like 1, 2, 4, 8, and so on, if you're doing diverging, well, then you get D&E, right? That's a very quick math problem because it's impossible. You just say, nope, I'm done. Can't do this one. So we're going to first establish, are we dealing with a converging case or are we dealing with a diverging case? And the way you figure that out is you look at the sigma notation, right? This is the shorthand for how mathematicians write these geometric sums. And you can see there's two things in this. There's the A1 value, which is right here. Let me get rid of that other guy. And then there's the R value, which is right here. You can, it's usually a pretty easy call. When you see an exponent, the exponent is on the R. Okay, so in this case, we have R equals -4/9 from the look of it. Now, that's less than 1. So in this situation, I've got a converging series. Okay, so that's what I'm dealing with here. I'm dealing with a converging because that R is an absolute value less than 1. So now we're going to use our formula and we say, okay, sum equals A1, which is -2/3 in this situation, divided by 1 minus the R value, which is -4/9. Okay, so this turns into -2/3 divided by, that's 1 plus 4/9, which makes it 13/9. Now, I don't have a calculator, so let's just try to, put on our big kid pants here. I'm going to turn this into a multiplication problem. Let's say -2/3 times 9/13. This is the old keep, flip, change thing. And that's going to equal to, let's see, once I reduce it, those are going to cancel out right there. So this is going to give me -6/13. That's my answer for this one. The answer is -6/13. Now, had this problem been a little different, okay, so let's play the what if scenario. What if, let me draw my box over here. So this is the situation. What if you have a scenario like this where n equals 1 to infinity, our A1 is still -2/3, but now we have something like this. -9/4 is your R value. Well, you would look at that and you'd say, yikes, the absolute value of R is greater than 1. Therefore, this is a big old D-N-E in that situation. Okay, so those are the two scenarios you have.